Okay, I have started recording. I hope it saves. Okay. So today we are going to be doing RMO P2. This is a algebra problem, and I am an algebra main. Okay, so you see three equalities. So the first thing you should do is just consider like one of them. Like consider each of the equalities individually, so you'll get B plus 2SC. Yeah. And well, if when in doubt, just like cross multiply. So multiply by BC and you'll get ABC plus 2C equal B square C plus 2B. Okay. Now this is already promising because we have B square C and we want B square C. So you can write the same equality, like do the same thing for this equality and the same thing for like the first equal to the third, and you'll get like a square b and c square a, right? And if you add all of them up, then okay, let me just write them down. So you have your second one will be abc plus 2a equal c square a plus 2c. Indeed, I am not skill issuing, I hope. And then it will be ABC plus 2B equal A square B plus 2A. Yeah. So if you add all of these up, you see 2C, 2C, like 2C, 2C, 2A, 2A, 2B, 2B. So these will cancel and you will get 3ABC equal some cyclic. Oh God, my handwriting sucks. Anyway, and like, so take absolute value on both sides. So this is what we need to find. We need to find 3 times absolute value of ABC. Okay? Now, now what? How do you find ABC? Well, the second thing you notice is this. Distinct, non-zero, and well, reals. So, well, reals doesn't matter too much here. Non-zero is there because we are dividing by B, C, and A. What about distinct? Well, you will notice that like if A, B, and C were all equal, then this equation is just true, right? X plus 2 by x equal x plus 2 by x equal x plus 2 by x. So 1, 1, 1 works, 2, 2, 2 works, 3, 3, 3 works. And all of them give like different values of this constant, which is why they have specified non-distinct. But the second question is, how do you use distinct? Well, the thing you can do with distinct real numbers is there's really only one thing you can do. Suppose you end up with, at some point, a minus b times x equal a minus b times y. So you want to cancel a minus b and say x equal y. But if a was equal to b, this would be, you can't, because you can't cancel 0 on both sides. You can't divide by 0. So this is like the only way you should think of whenever you see distinct, and the distinct is actually important, which it is here. You should realize that this is like the only way you will ever get to use distinct. So you want to create factors of a minus b, b minus c, and c minus a, and then you want to eventually be able to cancel them. Okay? So with that in mind, let's look back at this equation and, well, rewrite it a bit. So you have 2b and 2c. They are both linear terms, and you have b square c and abc. They are both cubic terms. So it makes sense you'd want to group them. So I'll write this as 2c minus 2b equal b square c minus abc. So like everything I've done here is like normal steps, right? You group terms of the same degree, you add up equations, etc. And now you'll notice, look here, if you can take 2 common here, and you'll get a factor of c minus b, which, as you know, we are looking for that. And here you will get a factor of, you can take bc common, and you'll get c minus a. Sorry, you'll get b minus a, right? Yep. And now you notice, okay, this is not what we wanted. We want to cancel like the same factor on both sides. You can't cancel c minus b with b minus a. But we have 3 equations. In the second equation, you'll have 2 times a minus c equal CA, like do the same thing for like equation 2. CA times C minus B. And do you notice something? There's a C minus B here. There's a C minus B here. When you multiply these equations, now you can cancel this. Similarly, write the third equation, which, you know what, fine, I'll do it. 2 times B minus A equal AB and A minus C. Yes. Now you multiply all three equations, and this cancels with this cancels with this cancels with this. So the motivation of writing the equations like this is specifically because you want to create terms like this. And you want to group homogeneous terms. Like I both are valid motivations. And the reason you want to create terms like this is because you want to use distinctness. Anyway, multiply this out and cancel the stuff. So you get 8 equal ABC whole square. So the magnitude of ABC is 2 times square root 2. So what did we want? We wanted 3ABC. So 6 square root 2. QED.